Hey, thanks for coming back here. I just want to make sure we didn't rush anything here. So let's go ahead and take a look at number 4. We had the left half of the black graph and the right half of the green graph. And on the boundary, they were both open because they did not have the or equal to in the inequality there. So we're going to try a couple more here. For piecewise functions, we're not going to do the increasing and the decreasing portion. We're going to focus more on the graphing of it. So taking a look at number 5, we're going to, again, cross off those increasing, decreasing, and constant, and focus all our efforts right now on how to graph this one. So as we're looking at this, we actually have 3 different rules. We want to graph the line y equals x, y equals 4, and y equals negative 3/2 x plus 2. The problem with this is that we don't just have like the left half of the graph and the right half of the graph. We have more than one boundary. So our first boundary occurs when x equals 8. So I'm going to go ahead and chop up this graph here at x equals 8. And this top one is saying you want everything greater than 8 for your x values. So that's going to correspond with everything on the right half of that graph there. For the next one, okay, so that's that top one. For the next one, I see my boundary happens at 8, but then also at negative 2. So here we're going to chop our graph at negative 2, and negative 2 is less than x, which is less than or equal to 8, means everything in between negative 2 and 8 is what we're going to want to graph for that blue line. So you would graph the whole blue line, and then you would chop it off at negative 2 and 8 and just have that middle section. Which then leaves our last boundary here, everything less than or equal to negative 2 would be the left half of this graph here for this green line. So the green line, we're going to only want the left portion of it with a boundary at negative 2. So we're going to take each of these and we're going to try to graph, first of all, the entire line, and then we're going to chop it at whatever boundary it has. So for this first one, we're going to think about the line y equals x. Normally my slope is 1 and my y-intercept is 0. So I can graph that line. So slope of 1, y-intercept of 0. And if I were to draw the whole line, that's what it would normally look like. But we don't want the whole line. The only part we want is the part that's in this yellow section here. Everything greater than 8 for that one. So what we're going to do is we're going to erase the other points and only look at the ones that are bigger than 8. So it's even just this tiny section up here. On our boundary here, we're going to have an open circle because at 8, we don't want to include it. We only want the things that are bigger than 8. So this blue line in the middle here, this would normally be the line y equals 4. So that would be a horizontal line normally all the way across 4. But we don't want the whole line. We only want the portion that's in the middle here, which means we're going to go through and we're going to erase everything that's outside of there. We're going to chop it at negative 2 and at positive 8. And then on top of that, what we're going to do is we're going to have 2 boundaries. So at each end here, we have to ask ourselves if it's open or closed. So at 8, that's the boundary over here. This is going to be a closed circle because 8 is included in this middle portion here because of the or equal to. At negative 2, it's going to be an open circle because we don't want to include negative 2 because there's no or equal to. And then our very last one, the one in green here, we're going to graph the line y equals negative 3/2 x plus 2. So my y-intercept here is 2. Make sure you're graphing this as a y-intercept, not on the boundary line. So go back to your y-axis and pretend there's nothing there and start at 2 and then go down 3, right 2, and up 3, left 2. Okay, so you see on our boundary line here, we're actually up here at 5. This boundary here is a closed circle because it has the or equal to, And we only want the part that's in the green over here, the left half of this graph, so we can then erase the other points that we graphed. So this would be the piecewise graph of this function. And so you can see there's three different lines, but there's only one piece of each of those three different lines. Today, we're still going to skip this next part. I still want to only focus on the graphing and make sure that goes okay, so you don't have to do any of the following below there. We're going to do one more graph together just to make sure that everything is going okay. So again, for this one, you can cross off everything except the graph. We're going to focus here in on the graph. So there are three different parts here. So we have equation number 1, equation number 2, and equation number 3. So I'm going to go ahead and draw my boundary lines. The first one happening when x is -2. The next one happening when x is 4. Then I'm going to label each one so that I know which part is going to be the yellow line, which part's going to be the blue line, and which part's going to be the pink line. So everything less than -2, at my boundary here of -2, the less than would be the left half. So the yellow line is only going to be in this yellow section over here. The next one here is the in-between one. So -2 is less than or equal to x, which is less than 4. That's the middle one here is that blue line, which then leaves the pink line for the right half. Everything greater than or equal to 4 means that bottom equation will be graphed on the very rightmost part of our graph grid. Let's start off with this yellow line here. This is the line y equals 8. So once again, normally this is a horizontal line across 8, but we don't want that whole thing. Again, we only want the portion of it that's in the yellow. So we're going to go ahead and chop this line and only graph the leftmost portion of it. And at the boundary here, this is an open circle when x is -2. The middle line here, I'll graph in blue. This is going to be y equals -1/2 x plus 1. So what you're going to do is pretend that there's nothing on our graph and graph this like normal. My y-intercept here is 1. My slope here is -1/2, so down 1, right 2, and up 1, left 2. And keep extending it until you have points in all of the different areas here so that we know which part we're going to use. So now we have these different parts. We are going to graph this in the middle section. So we only want the part of the line that's in that middle blue section. So that's going to be these points here. And what's going to happen on the left-hand side, you're going to have a closed circle because of the or equal to. On the right-hand side, that's going to be an open circle because it's just less than. Okay, so for our very last one here, we're going to graph the line y equals 3/4 x minus 8. So in order to graph this, you're going to pretend like there's nothing else on your graph grid, and you're going to start off with your y-intercept of -8. Now, careful on this. Warning, warning, some of you are going to want to go over here, and I totally understand why you would want to put your points there. But that's your boundary line. That's not your y-intercept. So please make sure that you are using your y-intercept of -8 down here. Then you're going to go up 3 and over 4, and up 3 and over 4 again. And this would be your normal line here. But we don't want all of this. We only want the portion that's in that pink portion or to the very right-hand side. So what we're going to do is we are going to use the right side of this graph, and we can erase any other points that were used. And this would be a closed circle at our boundary because it has the or equal to part there. So this is the graph of what this piecewise function would look like. You have three different lines, and you have one part of each line all put together on the same graph grid. So hopefully this helped with graphing piecewise functions. Let me know if you do have any questions though. Thank you.